It's kind of funny, right? We live in this world with self-driving cars that have these incredible, almost science fiction level brains, but then the camera on our doorbell or a robot vacuum still feels, well, a little bit dumb. It seems like all that amazing AI intelligence hasn't really made it down to the small, everyday things. Well, today we're going to dig into a research paper that might just be the thing to finally change all of that.
So let's just start with the big question right up front. Why can't a cheap little camera be as smart as a super expensive car? The answer really comes down to one word: power. I'm talking about computing power and literal electrical power. And that huge gap is exactly what this new method called YOLIC is designed to fix. See, on one side of this gap, you've got massive AI. This stuff lives in giant data centers, runs on racks of expensive GPUs, and just chugs electricity. But on the other side, we have what we need: tiny AI. This has to live right on the device itself, run on a tiny battery, and be super cost-effective. The whole challenge has been, how do you shrink that data center-sized brain so it can fit inside a tiny little gadget without making it useless?
Okay, so before we get to the cool new solution, we have to understand the old ways of doing things, because this is really where the problem becomes clear. For years, computer vision, getting computers to see, has been stuck between two main approaches. And spoiler alert, neither of them is a great fit for our tiny devices.
First up, you've got object detection. You've definitely seen this before. Think of it like quickly drawing a big, clumsy box around something in a picture. It's super fast, it's pretty efficient, and it tells you, yep, there's a person over there. But it doesn't care about the person's actual shape at all. It's a rough, good enough kind of approach. So it's fast, but it's also kind of sloppy.
Now, the second method is the complete opposite. It's the perfectionist, semantic segmentation. This thing doesn't just draw a box. Oh no. It looks at every single pixel in the entire image and decides if that pixel is part of a person, or the sky, or the road. It gives you this beautiful, perfect outline. The catch? All that pixel-by-pixel work is incredibly, painfully slow and takes a ton of processing power. It's precise, but just way too slow for a small device.
So that was the big problem. That was the trade-off everyone was stuck with in the world of tiny AI. You could either be fast and sloppy, or you could be precise and incredibly slow. What we really needed was a breakthrough, a way to get the best of both worlds, the speed of object detection with the accuracy of segmentation, all running on a cheap, low-powered chip.
And that is where this paper comes in. The researchers had this brilliantly simple idea to get us out of that trap. It's a clever little trick that completely changes the question the AI is trying to answer.
They called it YOLIC, which is just perfect because it stands for You Only Look at Interested Cells. And that's exactly what it does. Instead of forcing the AI to analyze the entire huge image, which is what takes so much work, YOLIC just tells it, hey, forget all that other stuff, just look at these specific spots right here. It's like instead of reading a whole encyclopedia to find one fact, you just jump straight to the right page. This simple idea cuts down the workload massively. Just look at this example for a smart parking lot. The AI doesn't need to waste any energy analyzing the sky, or the building, or the trees. It only cares about one thing. Are the parking spaces full or empty? So with YOLIC, you just define those parking spots as your cells of interest beforehand. The AI isn't actively hunting through the whole image anymore. It's just passively monitoring the only spots that actually matter. That little shift is everything.
So, how does it actually work under the hood? It's really just a simple three-step dance. First, you, the human, tell it which parts of the picture are important. Those are your cells. Second, the AI does a quick, low-effort scan of the whole image to get the general vibe. The shapes, the colors, the textures. But then, and here's the magic, for step 3, it takes that general knowledge and focuses all of its brain power only on figuring out what's inside those cells you defined. It just completely ignores the rest of the image. Think of all the wasted work that saves.
All right, so the idea is really clever, it's elegant, but does it actually work in the real world? This is where the paper gets really, really exciting, because they tested YOLIC on some very common, very low-cost hardware. And the results? Well, they're kind of staggering. Just look at this number, 40.06 frames per second. And that's not running on some liquid-cooled supercomputer, nope. That's on a tiny little Raspberry Pi, a computer that costs less than a new video game. This right here? This is the headline number of the entire paper.
Now, to give you some context, standard video is usually around 30 frames per second. So anything above that is what we consider smooth, real-time performance. YOLIC didn't just meet that bar on a cheap little device. It blew right past it.
This is an absolute game changer for affordable AI.
But you might be thinking, okay, is it only fast because it's bad at its job? And the answer is a big nope. Not at all. This comparison here proves it. On the left, you've got the ground truth. That's what's actually there. And right next to it, you can see what YOLIC detected. As you can see, it's a nearly perfect match. So it's not just fast, it's also really, really accurate.
And this table just drives the point home. Look at YOLIC compared to some other well-known, lightweight AI models. It isn't just a little bit faster. It's in a completely different universe. I mean, we're talking more than double the speed of its closest rival, and over 14 times faster than a really popular model like YOLO V8 on the exact same hardware. That is a massive difference.
Okay, so we've got a method that's super fast, super accurate, and runs on cheap hardware. That's awesome for researchers, but why should you care? Well, because this is the kind of technology that finally unlocks the door to a world filled with truly smart, affordable devices all around us.
The paper itself points out some amazing real-world uses. Imagine an e-scooter that can actually see potholes and warn you before you hit them, or a camera in a parking garage that instantly tells an app exactly where the open spots are, or tiny, cheap robots that can zip around a warehouse without crashing into things. This stuff isn't science fiction anymore. This is the kind of practical AI that YOLIC makes possible, right now.
The researchers knew how big this was. They actually wrote, and I'm quoting here, "This unprecedented speed and precision open up new possibilities for Internet of Things applications." Now, unprecedented is a really strong word to use in a research paper. That tells you this isn't just a small step forward. It's a fundamental leap for the billions of connected devices in our world. Of course, no technology is perfect, and the researchers are honest about the main limitation here. The magic of YOLIC comes from its cells, but the more cells you need to define to cover a really complicated scene, the more complex the AI model can become. So there's still a bit of a trade-off the developers will have to think about. All right, we have covered a ton of ground here. So let's just take a breath and boil this all down to the most important takeaways in a super quick recap.
So here's what you really need to remember. The big problem was that powerful AI was just too big and slow for our small gadgets. The solution? YOLIC's clever trick to only look at specific cells of interest. The result is absolutely blazing fast, real-time speed, even on super cheap hardware. And the impact? Well, the impact is that this could finally make all of our everyday things genuinely intelligent.
Which really just leaves us with one last question to think about. Now that we know it's actually possible to stick a fast, efficient AI brain into almost anything, what object in your daily life do you wish was just a little bit smarter? Your toaster? Your coffee maker? The possibilities are now pretty much wide open.